Hey, what's up, beautiful people? It's Shower Guy, and you're tuned in to Lauren and PJ Do Science. Today's episode is all about the AGU annual meeting down in New Orleans, Louisiana. Stay cool and stay clean. And now, Lauren and PJ.
Galileo, Newton's laws, Darwin writes on nature flaws, Curie, radium, and X-ray beams, Einstein, relativity, Watson, Crick, and DNA, black holes, Hawking, math, Copernicus, redraws a path. Lauren and PJ do science. She's got a doctorate, he's got a beat in lyrics. Lauren and PJ do science. Yeah, he's a broke musician, and she's gonna teach him.
Yeah, thank you, Shower Guy, and a Merry Christmas to you as well, my friend. It is in fact Christmas week when we are recording this, so we're gonna talk about like some more sciencey stuff, but we decided to take it nice and kind of light and simple and talk about the conference that Lauren went to, the AGU conference. But before we get that, Lauren, how you doing this week? Are you ready for Christmas, or just is everything mayhem like it is on my end?
Oh, it's a lot. I just submitted all the final grades for the semester yesterday, got back from New Orleans on Saturday, and now it's just like this mad rush to have everything ready for the holidays. And every Christmas feels so anticlimactic. It's like all this buildup, and then it's over. No big deal.
It does. I mean,
It's just so strange.
hashtag over commercialization of the holiday. You know, that whole
Yeah.
speech that Linus gave in Peanuts and the reason for the season, and never mind that it was, just marketing by the Catholics to steal away a pagan holiday. But anyway, we won't get into that.
It's very
too
funny,
much.
but last night, so we were setting up this little polymer clay nativity set that my mother-in-law got us, and I was telling Eleanor, our older daughter, about the nativity story, because like we're not really like raising our kids Christian, but like Christianity kind of saturates everything.
Yeah.
And apparently like she already knew who Jesus was because of YouTube, which I think is very funny. But I was telling her the nativity story, and I could remember the whole lo, there were shepherds abiding in the field, keeping watch over their flocks by night. Like I could remember like that whole thing for two reasons. One, because of the Charlie Brown Christmas, obviously. And two, because I've sung Handel's Messiah 3 times now in my life. And so I knew all of the soprano recitatives, and all I had to do was remember the words.
It's awesome. Yeah, I mean, and as a little kid, you don't know. Like, you don't learn until even people now don't even know that, like, if you look at the sky charts and they studied it and all that stuff, all this stuff happened in like April, But they're like, oh, it happened in December, and we just roll with it because it's fun. Whatever. It's all stories anyway. But we are not here to debate religion. Definitely not, because, wow, we don't want to piss anybody off. 3 minutes into this podcast, and we already alienated half the people. Well, then again, the people who are really deep into it don't believe in science anyway, so I don't think they'd be listening regardless.
So I think since it is Christmas week, we might as well, go there for just a split second. I think it's totally possible to be both religious and believe in science. And I know lots of folks who do.
Absolutely. Yeah.
And I think that if anything, being a scientist has made me, if not more religious, at least more spiritual in a way. Because like I get to study how the universe works, which is pretty godly, I guess. It's pretty divine. It's understanding the mechanisms behind everything, and it does feel like there's this sense of awe around it. And so if you're out there and you're a religious person, whatever form of religion that may be, you're welcome here. We don't look down upon folks who have religious sentiments on this podcast. And it's totally fine if you don't as well, because we're all here to talk about science, and we all love that. So
And we do welcome all, and hopefully, even the anti-science people, maybe we convert some of them to some of the science. Actually, I have a story about that. I was walking around with I have a They Might Be Giant shirt that says "Science is real," and some
Mhm.
lady comes up to me. She's like, "Science isn't real. It's all God's creation." And I just like that the wit popped into my head, and I said back to her, and I'm just going to use this line as every argument. I go, "Ponder this for a moment. What if science is God's way of letting us explore his creation so we can further appreciate his magnificence?"
Mm. What did
Right?
she say?
She just looked at me and said, "No, science isn't real," and walked away. I'm like, "Okay, sure. Whatever you want,
Okay.
lady."
I can't believe you
Anyway,
found one in the wild. That's amazing.
I I live in an area where Williamsburg's interesting. It's somebody once told me that it was newlyweds and nearly deads. So it's
Yeah,
yeah,
okay.
and the older people are like a mix of old hippies and just super conservative, like religious nuts. I mean, there's a couple in betweens, but that's kind of the way it is. Like it's a really, really interesting area. And I joke that I kind of because I moved up here from Florida, so I tell people that I moved from God's waiting room to almost God's waiting room. It's it's an interesting area. I mean, you have families here that
Yeah,
have been here since the beginning, like pre-colonial eras, because we've been established. Like, there's been people living here in some form, uh, Native Americans aside, of course, since like the 1600s. So you have some
right.
families that go back that far, but it's also kind of growing because it's been a college town for 350 years, so it's been growing from there too. So it's got a lot of interesting cats running around.
I hear that because, like, I'm in South Jersey, and so New Jersey is a very liberal state overall, but Atlantic County is one of the few red counties in the state.
Hmm.
Um, the presence of like rich people, wealthier liberals at the shore, notwithstanding, there's a pretty big conservative presence here. We're firmly in Trump country, um, and it's a very weird dynamic. I would say there's a strange mixture of like, it's pretty ethnically diverse, religiously diverse, but also the further west you get, the deeper into the Pine Barrens you get, the more conservative and white it becomes. And it's very much the same thing where you have families who have literally been here for 300 years,
Hmm.
my own included. Like, I'm descended from some of the founding families of New Jersey on my dad's side. So I have a lot of like distant cousins all over the place down here. And it's just like this very strange mixture of politics. Um, but at the same time, so much money is invested in education in New Jersey, um, because it's a more liberal state overall, that I think it's not as bad as some other places. But I have heard New Jersey, South Jersey, described by someone from Trenton as Alabama with a Philly accent, and I felt
It's not
called out
wrong.
and seen at the same time. Like,
Yeah, it's
it's
not
true.
wrong.
It's
Yeah.
not wrong. Um,
We
so
we just got
I mean,
a bunch of NIMBYs here. Like
oh
they
yeah,
complain about everything. Like Amazon was looking to like the old Williamsburg pottery land is just a massive like tract of land. And Amazon was looking into putting a warehouse there and everybody was like, "No, we can't do that." But then the other half were like, "It's going to bring 1 billion jobs to the community." "No, we still can't
right.
have that." Then people sit around and argue why we don't have a Costco, why we only have like one hospital. I'm like, well, you're not building things to attract people to want to live here. And those things only come about if you attract people to live here. Costco isn't, we have a
Yeah,
Costco down like a half hour away, but they're not going to build one here if the population doesn't really justify that. So you can't have it
yeah,
both ways. But they whine
that's
about
how that works.
everything. Like next
Mm,
to Busch Gardens is a community and they complain that they can hear the train whistles from Busch Gardens. The theme park train that just goes around. They complain that they can hear
right.
that from their
Oh, for
backyard.
God's sake.
Not in their house, just their
Yes.
backyard they want. And like every time they go to build
Oh,
a new
how
roller
sad.
coaster, they're like, "Oh, are we going to hear the screams from here?" Just shut up. Stop whining. Anyway,
Ridiculous.
back to the topic at
Yeah.
hand, the AGU, the conference. So, a little background for all y'all good people on the American Geophysical Union. They've been around since 1919, so they've been around for a minute. And I was looking up; it includes atmospheric, ocean, hydrologic, space, and planetary scientists and enthusiasts. It covers like a huge variety of different kinds of sciences. So it seems from the research I've done, they're like one of the big groups, if not like the biggest group of scientists that do what they do. I'm sure you could
Yeah.
probably explain it
Yeah.
way better, but that's kind of like what I in 5 minutes of looking up before this episode. I wanted to do more looking and research, but I didn't have time.
Yeah. So I've been, let's see, I would say I've been going to AGU meetings since I was a postdoc. So the American Geophysical Union, like you said, basically covers all of the earth sciences. So geology, atmospheric science, astronomy, planetology, oceanography, hydrology. So anything to do with the physical processes that control what happens on Earth and on other planets as well. And so I've been there under a couple of different contexts. I presented 2 different talks at this particular meeting on 2 sort of related but very different topics. One was from some work that I did during my first postdoctoral appointment at Michigan State University, and the other was on some work that I'm doing now with my students. And so, where would you like me to start? Like, do you want me to talk about the conference more broadly and then talk about what I do, or how do you want me to do this?
Yeah, let's start like broad and then bring it in. So yeah, talk
Okay.
about the conference as a whole, and then we'll break it down for the people.
So, I went to a bunch of different sessions. So the way that these larger conferences work is that everything's split up into sessions on different topics. And a conference this size is so big that there's multiple sessions going on at the same time. So there's no way to see every single talk that's given. But it's just a way for scientists to present their ongoing work to each other. A lot of times it's stuff that hasn't been published yet, or it's in the process of being published, so it's very, very new. There'll also be invited speakers who will give longer talks that are a little bit more broad, about all kinds of different topics. It could be stuff relating to public interest or the future of science or the future of their particular field. It can be retrospectives. It can be all kinds of different things. So I saw all kinds of interesting science being done. There are folks who were looking at data from the Juno mission, trying to sort out what's going on the moons around Jupiter. I saw some talks on new technology in studying the oceans, and different ways to overcome funding limitations in ocean science, because going to sea is very expensive and all the equipment involved is very expensive. So there are folks who are presenting different methods for getting data inexpensively and quickly. I saw folks talking about carbon cycling and carbon storage in places like wetlands and salt marshes and forests. People talking about climate change and what we expect climate change to do over the next couple of decades. Deep sea
It reads
mining.
like a horror story.
Yeah, deep sea mining was a big topic. So a lot of folks don't know that there are plans to start doing intensive mining in the seafloor in international waters in the next few years, because they're good sources for rare earth metals like manganese, for example, mostly for making batteries. So for things like electric cars, computers, cell phones, you need certain types of metals to make the batteries. And generally, we get these from mines on the African continent. There's a lot of child labor and slave labor involved, which is pretty terrible in and of itself. But multiple countries are looking to the seafloor as a source for some of these minerals. And the problem is that we don't really know what's going to happen if we start just digging huge holes in the seafloor.
Yeah, that's I can't
Yeah.
imagine fracking the seafloor. That would be bad. My other
Yeah.
question is like deep sea mining, what are they going to use as the canary? Like, are they going to use a puff, like some sort of fish to be the canary? Like, how do you tell that? And follow-up question, I guess you could probably use like an anglerfish as your lantern because they got the little lights on them. But like,
I don't I don't
I
think that
don't.
and that is the problem, like metaphorically speaking, there is no canary. Like we don't really know what the long-term effects on the seafloor ecosystems are going to be. Um like I saw a talk that I think it was done out of Germany originally, and this was something that was done a few years ago. They basically mimicked what deep sea mining would do to the seafloor, just like dug it up. And they projected that it would take 50 years for the communities within that seafloor to go back to normal after
Oh,
just
lovely.
dragging it. Yeah. And like, I know that a lot of folks hear, like, oh, so you're just tearing up the seafloor. Like, what's down there that's so important? You know, like, who cares?
Hmm.
And I understand that, a lot of folks don't understand because no one's ever like taught them that the bottom of the sea floor is home to communities that perform a lot of really important ecosystem services, which is basically things that benefit humans indirectly. So of course there's things like storing carbon in the long term to prevent it from getting in the atmosphere and warming up the planet, but there's also things like feeding fisheries so that we have seafood. And all kinds of other processes that we don't fully understand. And so going into the ocean floor and basically digging up huge chunks of it without knowing what the long-term effects are going to be on that, not just that area, but the ocean as a whole, is really risky. And it's very scary to people like me who study these processes and realize that they're extremely complex. And it's not just about preserving the diversity of the seafloor, which is important in and of itself, don't get me wrong, but for folks who don't care about stuff like that, like fish diversity or corals or whatever, these ecosystems also provide indirect services for human beings that we haven't fully worked out the mechanics of yet.
Sounds like a
So
new
it's
episode.
yeah, we might have to do a whole episode just talking about deep sea mining because
Yeah.
it's such a big
Uh,
topic.
And I was gonna say, like, to your point, most people think about the deep sea. All they think about is like these weird critters that kind of look like biblically accurate angels that glow
Yeah,
in colors that the human eye can't comprehend. But yeah,
right.
there is a lot
Which is
more
all
to it.
very cool. It's all
Yeah.
very cool. Yeah. But I realize that there's like a not insignificant portion of the human population that's just like, why should I care what happens to weird looking fish?
Right.
Um, and I understand that like it's not obvious what the direct benefit is to human beings that these ecosystems remain undisturbed. But
Well, at the very least of it, I mean, I can kind of appreciate it because you got like some sort of plankton rolling around on the ocean floor. A fish eats that. That fish lives up a couple feet, and that fish just keeps getting eaten, 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 and so on and so forth up to the depths of the ocean. And next thing you know, you catch a grouper that ate a fish that ate another fish that many generations ago ate like a plankton living on the deep sea floor. So at the very least, you
yeah,
have that.
yeah, at the very least, exactly. You're talking about the base of the food web, right?
Yeah.
And supporting um, shellfish and fisheries, which are huge industries, right? Um, like if the fishing industry worldwide just collapsed tomorrow, that's billions, if not trillions of dollars, untold numbers of jobs. So that alone is reason to hesitate to disturb these ecosystems. But then on top of that, you do have things like long-term climate control. Um, and that's not just controlling the temperature of the planet, but also the overall weather, like the production of superstorms and things like that. So there's just so
Mhm.
much going on. There's so many different processes involved here. And I'm not saying that, we don't need these metals to make these batteries. I mean, if we want to have more sustainable energy solutions, right, we have to have a way to store the energy generated by solar and wind power. Um, but at the same time, we have to tread really, really carefully in terms of how we acquire the metals that we need to make these batteries.
Yeah, it sounds like a lot more research needs to be done in that. But yeah, back to the conference. It sounds like it's more than just like
Mm.
lectures and stuff. Like it sounds like people were bringing their work and collaborating with other scientists and people and trying,
Oh yeah.
which is by the way far from the kind of conferences I've ever gone to, which are like, you show up in cosplay, you go to Artist Alley, you go to the merch tables, you get into a
Well, I've been
DDR
to those too,
competition,
yeah.
like does anybody cosplay at these things? Because you come dressed up as like your favorite element. That'd be fun.
I wish. I wish dressing up was more mainstream at these things.
You know what?
I
You have
like
the
to
power to
wear
change that.
I would like to think that I wear very stylish, very distinctive outfits at these things. Every single day at the
Yes.
conference, I was getting compliments on my outfits because there's basically two types of people at a conference. There, especially at a geophysical conference, anything to do with geology. You have people who dress like me, like basically like Miss Frizzle, and then you have people who look like they just got back from camping or are about to go camping. Um, and then those are basically like the two stylistic types at most of these things. But
Yeah, and
yeah,
then you would have
there's
me who rolls up in like a Hawaiian shirt or something like that and be like, "Yo."
no, that's the oceanography conference.
Then
So
that's my people. That is my people.
yeah, if you go to
Clearly.
an oceanography conference, there's a bunch of guys who look like they're about to go surfing, and they're all in Hawaiian shirts. So that's how you can tell who the oceanographers are.
That's about
But
right.
yeah, so there's lots of talks about research, and they're very short. So the time slot was only like 10 or 15 minutes, depending on the session. Just
Oh wow.
very short amount of time. Yeah, very, very short. You're lucky if you had time for like one or two questions at the end of your talk. Um, and then there are also what are called poster sessions. So when you submit an abstract, your little blurb about what you want to present at the conference, you submit that to the particular session that you want to present in, and the folks who are putting that session together will decide whether they want you to give a talk or they want you to present it as a poster. And a poster is exactly what it sounds like. It's a big piece of paper that has all of your figures on it and a summary of what you did. And there are poster sessions where you stand by your poster and people come by and they look at your poster and they ask you questions about your work. So I did both. I gave a poster Wednesday morning and then I gave a talk Thursday afternoon.
So that poster talk thing is kind of like a big old science fair.
Very much so. It's very much
Okay.
like a science fair. People just kind of like walk around and look at all the different posters and ask people questions. I almost prefer poster sessions to talks because I feel like there's a it depends on the size of the session. There's a potential to reach more people with a poster, depending on how many people stop and talk to you, but also it's more like a conversation. It's like a dialogue. Um, and you're not rushed to squeeze all of this information to a very short period of time. So you get to have like a conversation with the person standing there and they ask you questions and you answer the questions. You get to like point to different spots on your poster and it's a lot more relaxed. And I feel like I get really good interactions that way. Whereas with a talk, like with my talk, I talked for the full 10 minutes. There was no time for questions. I sat down. I didn't really get to like interact with anybody about my work afterwards.
So, all right, I'm kind of putting this together, like with the conferences and conventions that I understand, which, I'm sure you're very well aware out there listening. Anime conventions, Star Trek conventions, Comic Cons. Okay, so check it out. The panels, of course, are pretty similar, where you have groups of people educating, but the poster talk is Artist Alley, right?
Yeah.
Because you get one-on-one
Yeah.
time with the artist to ask them about their craft, and they're showing you like their art. So, I mean, while you're not necessarily
Yeah.
buying anything from the scientists, but you are kind of doing the
Right.
same thing where you're talking to them about it.
Yeah.
So there's your
Yeah.
Artist Alley.
It's definitely yeah. And then we had town hall sessions, which were more like panels.
Right.
Where we talk about you have a group of people at the front of the room talking about a particular topic for an hour or so, and they invite feedback from the audience. I went to a couple of those. Some of them I thought were a little bit more interactive, I guess, than others. I went to one that was about integrating art into science, which I found really interesting, and it sparked a lot of really good conversation about like how do we remove this barrier separating art from science and mix them together more effectively. And I
Interesting.
really
Yeah,
enjoyed
talk
that
about
one.
that more, because that's interesting to me.
Well, there were a couple of folks who presented different projects where they worked with an artist who or artists who helped them present their work to a more general audience. There was one that was really interesting. It was basically like a group of composers working with climate scientists, and they
Mhm.
like put together this concert um, that basically like showcased climate science research, but also the emotions surrounding climate science research. How these people feel about watching the world change and how sad it makes them, like that
Mhm.
like they're watching this disaster in real time, and they're having a really hard time explaining to people why it's so important. And so the concert had musical pieces. It had like pieces for voice. They worked with indigenous people as well, like the indigenous peoples of Alaska, um, to kind of put together this like beautiful concert all around climate change and the loss of ice up north, and how people's lives are changing for the worse. And it was really amazing. And then there were some other ones, around conservation, all different kinds of stuff.
Yeah, and that's
I
kind of
thought
where
it
I
was
was
really
going with
fascinating.
this,
Yeah.
was like with the music thing, because that's kind of been going on for years. Like, I've always viewed music as a science in and of itself. Like, obviously, I mean, most people know that there is just a crapload of math involved in music. But,
Oh, yeah.
I mean, people take inspiration from what they see in nature. Songwriters have been doing that for thousands, millions of years. Like, since music
Mhm.
began, people have been taking that information from that. And even something like, Gustav Holst, The Planets. That's a
Right.
scientific piece because he wrote those pieces about the planet. I saw something really cool though on Facebook the other day. It's like a speaker with two electrodes on it, and they hook it up to like mushrooms or trees or basically
Oh, I saw
anything that can
that.
conduct. Yeah, and it gives like it interprets the electrical currents that's being put through that and says, "All right, this is the music that this mushroom is making." I'm like, that is so incredibly cool. And I
Yeah.
guess there's different ways to like tune it and make it do different noise, but like, a tree could be like dubstep, and another one like just came out with a beautiful piece of like just music, and this is the sound of nature. So that would be involved with a situation like that. But also artwork, like we've all seen the artist rendering of galaxies. Obviously we don't have a picture of a galaxy 10 million light years away, but we've seen an artist rendering of it.
We have some pretty good images now coming from some of our really good telescopes that show some of these incredible images from space. And I just there's just so much potential there for a collaboration with artists, like all of the beautiful things that we observe in nature. Like you were just talking about turning these electrical impulses into sound. Um, I think NASA put out something similar where they were taking the radiation coming off of Jupiter and converting it into
Yeah.
audible sound. So you could
Dude, that was
hear the planet.
creepy. That was
Yeah.
really creepy.
Sounded like the monolith from 2001, which was amazing.
Yeah.
Um, but I love that idea. I love the concept of taking things that um, we're studying and turning them into something artistic. And it's something that I've been working on for a while with my bog iron research, which I'll talk about in a sec because that's the thing that I gave the talk about on Thursday. But taking some of these images that I take lots of like pictures of the bogs and macro shots, zoomed in shots of the microbial mats, or turning that bog material into like imprints on paper, using textile arts. I mean, there's just so many different ways that you can take these incredible things that we observe and turn it into something beautiful that evokes an emotion. So you're not just looking at data in this very sterile, dry, quote unquote logical way. You are experiencing it. And I think that that's something that existed as a part of science for a long time. And we sort of got rid of it over the years. If you read some of these older scientists or natural philosophers' works, they are deeply emotional.
Mm-hmm.
The way that they talk about what they're observing and how beautiful it is. I mean, there's excerpts from On the Origin of Species by Darwin where he talks about endless forms most beautiful. He's talking about the diversity of life in this very poetic way. I think that there's absolutely lots and lots and lots of room for art and science to collaborate. It's something I've been harping on for years and trying to get more involved in myself. It's one of the reasons why I'm doing this podcast, is because I think that scientists do tend to be really insular. And while it's really cool to go to a conference and talk to other scientists about the science that you're doing, I think that there's no point in doing all of this if we keep it to ourselves.
Right. And if you break it down even to its very beginning, like art is entirely dependent on science. Like, where did the first pigments come from? Plants,
Mm.
bugs, those sorts of things. Like that all, and how are colors today created? Like the Pantone broke the internet with whatever color that was. How was that color created? Through science. What is, how do they determine which styles work best? Research. That determines the clothes you get. Research is a science. Like it's all tied back to the world of science.
Yeah. My one really conservative take about education is that I want to bring back the 7 liberal arts that were taught in the Middle Ages.
Mm-hmm.
Because each one of them is just a different way of looking at math. So music is math that's turned into sound. Um,
Yeah.
so like I 100% agree that music has this very mathematical quality to it, but also that you can flip it the other way around and say that like an understanding of music helps you understand math better. Um,
That sure didn't help me.
no, I think it does. It all depends on how you're taught, you
Look,
know?
I can count in base 8, and I know my 1/2, 3/4, and 4/4 fractions. But that's it. it's it's as far as my math goes.
Ah.
Yeah.
Well,
Well, you know what? Lo and behold, I found out many years later I have dyscalculia, so that explains a lot of things.
honestly, like, ugh, there's so many. I don't know. I we could go on and on about education of science, and maybe that'll be a whole separate episode in and of itself.
Oh,
But
it will
like,
be. It will be.
I I do think that learning science and learning math, so much of it comes down to meeting people where they're at, um, and teaching people that science science is accessible. It's not this like written in stone set of facts that's passed down from gods up on top of mountains that you have to memorize and internalize. It's a process that was done by people. Um, And it's for everyone, you know, just as art and music are for everyone. I think that there is a feeling that a lot of people have that like they can't do science because they're not smart enough. They can't do art because they're not talented enough. I don't I don't think that that's the best way to approach these things. I think
No,
that
and I
you
can
can.
completely attest to that. Like, that's kind of why I went down the music road because that was easy for me. And of course, at the time, I didn't realize it was science. It was just like, I'm going to play music, get girls, something, something, get famous, you know? A lot,
Right.
I still play music. A lot of that didn't happen. But, like, in school, it was memorize. All right, you got the nucleus, you got the proton, they swirl around, you got the atoms. This is memorize a periodical chart. And with a learning disability, I couldn't do that. Like, I can't memorize things really well
Mhm.
like, it just takes me longer. So I was always getting bad grades in science, and that kind of pushed me away from it until my adult
Mhm.
life when I kind of got back with it and was like, oh, I still can discover this entire world of science and things that are interesting, and I can still be interested, and it's still okay to like physics, et cetera, et cetera. I can be bad at math, but still appreciate how physics work, you know? Like,
Right.
I don't have to memorize every single piece of information, but I can still read these publications and like watch YouTube videos and stuff. And again, like you said, that's part of the mission of the podcast, is to make it accessible to people and encourage people to go out and do some of the research on their own and say, like, hey, here's some dopey musician over here. If he can figure it out, you guys can.
Yeah. What is this podcast if not the marriage between art and science? What else are
Exactly.
we doing here?
Yeah,
Yeah.
we and you know what? Actually, speaking of that, I have a challenge for you.
Mm.
With next year's conference. It is being held in Glasgow, Scotland,
Oh,
right?
yes.
As you know, I am an avid golfer, and we all know where Goff was born, Scotland,
It's
right?
true. Yes.
So maybe if we can get invited to the conference to do a live show, I know it's a big ask in a year, but maybe if we can get invited to the conference, I'm just saying there's somebody who would appreciate doing a live podcast and would definitely appreciate the surroundings of Scotland and the golf that it has to offer. Granted, going this time of year sucks because the weather is terrible in Scotland right
Yeah.
now, but
Yeah.
I am prepared to make that. I've made that sacrifice before golfing in bad weather in Scotland, so I am prepared to make that sacrifice again. I
Okay.
am
I mean,
willing to make that trade off for this show.
I think that we could make it happen. I really do.
Look,
I
that's all
I
you.
don't know. I think that there's ways to do this, right? Because what I would really love to see is more of this sort of thing, more of these dialogues between art and science happening at the conference. And I was really happy that they had more than one of these panels about science and art and how to integrate them, and they had artists there talking about their work. And I think that we should encourage that, if nothing else. So, I mean, I'm all
All
for
right.
it. If we can get the
So
money,
I
do
looked him up. Brandon Jones. Brandon Jones, if you're listening, invite us to the conference next year.
it.
And hopefully we'll have figured out how to do this podcasting stuff, and we'll have something much better together. We're learning, people. We're learning. It's
We
another
are.
science. We're learning. We're learning. We're
It's a
learning by doing.
process. Yes, we are
Anyway, yeah,
learning
we
by.
don't have too much time left, but why don't you touch on the talks that you gave?
Sure. So I gave a poster Wednesday morning, which, like I said, was on work that I did as a postdoc. So I've been throwing that term around, but I don't know if everybody knows what that means. A postdoc is kind of like you finished your PhD and now you're doing research in someone's lab, kind of as you're not quite an apprentice, more like a journeyman. You know, like you have a position in someone's lab for 2 or 3 years. You do research with them. You don't have any teaching responsibilities usually. You're just doing research and
Okay, so let
building
me
your
equate
research
that real
effort.
quick. Then let me equate
Yeah.
that real quick.
Okay.
Scrubs, like JD, Turk, all those guys. That's kind of the
Residence.
same thing.
Yeah.
Yes.
You're like a
Okay, cool.
resident. Yeah.
I
You're
love
like a
Scrubs.
resident doctor.
Anyway, okay.
Yeah. Actually, when I was explaining it to my dad, he said the same thing. He's like, "Oh, so it's like a residency program." I said, "Yeah," because he was asking, like, "Why don't you just get a job as a professor, why do you have to do a postdoc? And I said, well, you have to get this extra training. And he's like, oh, so it's like your residency. I said, yes, it's like a residency.
Mm-hmm. See, I always like your
So
dad. He's a smart dude.
yeah, well, the apples don't fall far from the tree. So I have a lot to thank my dad for in terms of getting me into science, but that's another story. So this is from my work that I did at Michigan State University. I was in the geology department, and I was working for someone who is also an oceanographer by training, and in particular, he's interested in the chemical reaction between rock in the seafloor, a particular type of mineral called olivine, and how it reacts with water to form another mineral called serpentine. So it forms serpentinite rock. And this process is called serpentinization. And the reason why it's interesting is because when water and minerals react with each other, they produce methane gas, hydrogen gas, and small organic molecules that microbes can use as sources of energy and carbon.
Okay.
It produces a kind of a harsh environment. It's very alkaline, so as opposed to being acidic, it's got a high pH instead of a low pH. Up to like 11 or 12. So not quite like bleach levels of alkaline, but still pretty alkaline.
Okay.
So it's not drinkable water at that point. So microbes live in these really like harsh environments, feeding off of this energy from this geochemical reaction. And the reason why it's particularly interesting is it's twofold. One, there was probably a lot of this type of mineral on early Earth, and so this reaction was pretty prevalent on early Earth, and it might have been like the starting materials for the origin of life. And for that same reason, it might be the starting material for the origin of life on other worlds in our solar system, particularly icy moons of Jupiter and Saturn, because these are places where there's an ocean covering a rocky sea floor. So this same reaction might be occurring on these other worlds as well. It might also be happening in the subsurface of Mars, or maybe it did in the past. But I think the jury is still out on that one.
Mm-hmm.
So I was looking at microbial communities in rock in Northern California in a place called the Coast Range ophiolite. And an ophiolite is basically just a chunk of seafloor that's been lifted up and put onto the continent, trapping the seawater inside of it. So it's a way to study this process that usually occurs at the bottom of the ocean without having to actually go to the bottom of the ocean.
So, like, you basically played a claw game. The claw comes down, picks up a chunk of seafloor, plops it on the deck, and you're like, oh, look at all these prizes in here.
Something like that, yeah.
Okay.
So it's this really, really huge formation on the coast of California. I think I've also been to the most extensive ophiolite in the world, the biggest and the best studied, which is in the Sultanate of Oman. And I went there while I was working in that same lab, and I published some work on that recently. But this was from work in California. It's about 3 hours north of San Francisco. You drive up through Napa Valley to get there, which is really nice. So we would stop at this.
How terrible driving through Napa. Oh no.
Yeah, get some wine, get some.
The sacrifices you make for science. Let's not
No. Science is hard.
I'm so proud of you. You've come a long way from the peat bogs of New Jersey to the Napa Valley. I'm proud of you.
We'll get back to the bogs. Don't worry, we'll get back to the bogs. But yeah, so I was studying this microbial community deep in this rock and just figuring out like who's down there. Interesting species, some species that are usually associated with this serpentinite rock. I found one species that was really, really prevalent called Desulforudus audax viator, which is named after Journey to the Center of the Earth.
Desulforudus
audax viator.
Sulforudus audax dinosaur. No, Sulforudus viator audasaur. Journey to the Center of the Earthism. Okay, cool, got it.
Yeah, they called it that because this microbe has been found miles underneath of the surface in like deep rock, just vibing.
Okay.
So yeah, and I think it lives off of um, minerals that have been lysed by um, radio waves, basically radiolysis. So like low frequency energy that breaks rock apart. They live off of the energy released by those minerals being broken apart. So they're really fascinating.
Hmm.
I was looking at those guys, and just trying to sort out what they do, but mostly through DNA sequencing. Um, and I was also characterizing some of the compounds that they release into their environment through their metabolism. So just basically like the byproducts of whatever they're doing. Their poop is one way to think of it, like just whatever they're releasing into the environment.
All right, so and go with me here. I'm thinking of like nuclear fusion,
Yeah.
right? Where they run based off of the energy, and the energy winds up being a byproduct. Like these things break apart like an atom does, right? And the byproduct of that is energy. Is that right, or is that?
It's sort of like that, but not on as quite of like a
Yeah,
dramatic
a very tiny
scale.
scale. Yeah.
Yeah.
Not like
So
Oppenheimer.
yeah, when you split an atom, you release a huge amount of energy, right? That's how atom
Yes.
bombs work.
Yeah.
But in this case, you're just breaking a chemical bond. So energy is stored in chemical bonds. That's why when you eat food, you get energy from your food because you break the chemical bonds that hold that food together and you release the energy stored there, and that's what you're using to run your body. So it's the same thing basically, except they're not eating food, they're eating rock.
Mm-hmm. Like the Gorons in Legend of Zelda. Got
Like rock fighters
it.
in story. And
Yeah.
speaking of rock fighters, so my my other project, the one that I gave a talk on Thursday, is closer to home. So this is the bog iron stuff in New Jersey that I've been working on. And these are places where in New Jersey we have really, really iron rich groundwater.
Mm-hmm.
And so the
That explains a
groundwater,
lot.
yeah. Well, it actually does. So the iron-rich groundwater in some places comes up to the surface. It forms all of our rivers and lakes and streams, but it'll also form these like really shallow places called seeps that are just a couple inches deep. And in these places, all of the iron in the water reacts with oxygen in the air and turns into rust. That's what
Mm-hmm.
happens. That's how rust is formed. Iron and oxygen react and form rust. So this process can happen on its own, but in this case, it's accelerated by microbes living in the seeps. So they actually take the iron and they use it as a source of electrons. They pull an electron off of the iron and they use it to turn carbon dioxide into sugar. Similarly to the way that plants do, plants use energy from sunlight and they pull an electron off of water to turn carbon
Mm-hmm.
dioxide into sugar. These guys use energy and electrons from iron to do the same thing. And they form these huge mats that are rust colored and pretty extensive in some places. And so my lab for the last 4 years now has been studying the microbes that live in these bog iron seeps and trying to figure out what shapes the community structure, like which species do you see in different places and why, what different processes are they carrying out, what different relationships do they have with each other. And so we've characterized a bunch of different microbes that have this capability. And then we've also found microbes that take the rust and they respire the rust in the same way that we respire oxygen. So they breathe rust.
Huh.
Yeah.
Okay.
Including a species called Geobacter, which builds these little what they're called is nanowires, and it's basically like this little structure that comes out of the cell, and they can use it to connect to a source of electrons. So you can grow them off of an electrical current.
Hmm.
They will conduct electrons along this little nanowire, and they'll use it to fuel their metabolism. So you can basically feed them an electrical current, and they can live off of it. So you can use them to make like biological batteries and stuff like that.
So that's like oh God, what's his name in Spider-Man? Um Oh, what is his name? I can't think of it. Somebody's gonna put it in the comments, somebody, because I'm not even gonna try. But interesting that they eat the rust. So that explains all the
Hmm.
mafia activity in Jersey, because you throw the weapons into a bog, they get all rusty, and these microbes come and eat and like breathe in the dust and eat it, or breathe in the rust and eat it, and then the weapon's gone. It
Something
makes
like that.
sense. Jimmy Hoffa is in a bog in Jersey, surrounded by the. Okay, I get it now. Okay,
Probably
got it.
covered in orange ooze as we speak.
More than likely, yeah.
Hmm.
Okay, I get it. It's plausible,
So yeah,
right?
keep an eye out for those publications.
Yeah.
Because I'm hoping to publish both of those studies pretty soon. I actually got a really nice grant from the National Science Foundation to cover the bog iron work, so we even um, expanded on that some more to include better probes that can measure some of the geochemical parameters long term in the water, so monitor things like the pH and the oxygen concentration in the water and the temperature and the water level over long periods of time. Um, and a lot of folks, when I tell them about this work, they're like, okay, but what's the point of studying these microbes in the bog iron? Like, who cares? And there's actually a couple of different applications for these. So I mentioned like the biological batteries, which is pretty cool. These iron oxidizing bacteria can be beneficial and they can also be a nuisance. So they can clog iron pipes because they'll grow on the iron and cause what's called biofouling. So it's basically just, slime growing on a surface and clogging it up. But the rust structures that they produce are also really good at binding up metals that are toxic. So binding up things like lead, arsenic. So they're actually really good at cleaning water as well. So we can use them for that purpose. And then in general, it's just a really good place to study how microbial communities are structured in the environment, what drives their structure and the relationships between them in this very small space, this depth of only a couple of inches. It's very easy to access. It's a great place to take students to teach them about environmental microbiology and microbial ecology. So I take students out to these sites all the time, a couple times a year, to collect material, bring it back to the lab, extract the DNA and the RNA and sequence it. So the RNA is proving to be really annoying to extract. As we just discussed, RNA is weird.
Yeah, it has a mind of its own.
It does indeed. But yeah, we're really making a lot of headway, and I'm using that money from the NSF to provide summer students with housing and salary so they can work for me over the summer. They don't have to choose between getting a job and getting experience in the lab. They can, focus on their studies and get more experience working in science. So
Look at
that's
you
been really great.
educating the youth of America. No, that's really
I'm,
awesome. I mean,
I'm
like,
doing my damnedest.
like a lot of people don't get that the ground is that complex. Like most people just see dirt and like, all right, it's worm poop,
Right.
and they don't
Oh,
realize that there
soil.
are just insane communities living underground that have, I mean, they're not obviously not the level of inhuman intelligence, but they kind of function the same way as our communities do, where we have these complex relationships and work together. And it's fast. It's insane. Like it's
Absolutely,
crazy.
absolutely. There are these vastly complex communities of microorganisms that live in soil and in water that basically maintain the ecosystem. They cycle nutrients. They're the base of the food web. They provide, again, all of these really important ecosystem services. And they are incredibly complex. And it's a way for us to understand how life works at the most fundamental level. And so I don't know. I just find all of it super fascinating. That's why I love studying slime. That's why every time I see like some weird growth on something, I'm like, "Oh, I wonder what's growing in there. I wonder what it's doing," because there's all kinds of complexity there. There's microbes that can do all kinds of really weird things. Like I just talked about the ones that can conduct electricity, which is pretty bonkers. There's another one that lives in our bog iron communities that literally creates its own little compass needle so that it can orient itself with Earth's magnetic field.
Okay.
We think it's to help it like find its way through gradients of nutrients or whatever else it needs, but it literally is like a little compass.
So it has like its own homing device to find food. That's bonkers.
Yes. Yeah. Microbes communicate with each other. They sense their environment, and they go towards things that they want and away from things that they don't want. They move in all kinds of fascinating ways: swimming, twitching, crawling, rolling along treadles like a little tank. I mean, you name it, a microbe has thought of it. And it's all like the basis for all of the complexity of life that we can actually see is supported by this invisible world.
I
So
think
yeah, I could go on and on about
yeah,
how cool microbes are.
I think we need to polish off that song I wrote a couple years ago. Why should I care about people when microbes rule the world? We'll do like
yes.
We'll need like a 10-part episode on that or something crazy.
Oh my god, we could do many episodes about microbes and how they rule the world and polish it off with that song. I think that would be fantastic.
Yeah. All right, cool. So, final thoughts on the conference then as we wrap this one up.
So, this year's AGU was significantly smaller than last year's AGU. And it really showed. So last year we had 40,000 people in attendance at this meeting. This year it was 30,000.
Okay.
So it dropped by like 10,000 people, by like 25%. A lot of sessions felt empty compared to previous years and really quiet. And there were just fewer people around, and a lot of people who were supposed to be there couldn't be there at the last minute. My tech, for example, was supposed to give the talk that I gave on Thursday, and at the last minute, he was unable to come. And it was because he is a Venezuelan refugee, and he was afraid to travel.
I don't blame him.
Yeah, and in particular because the conference was in New Orleans, and ICE is really out in force there in particular. He just didn't feel comfortable going, and he wasn't able to give the talk online, so I had to give it. And a lot of people couldn't go because they were government employees and they were told they weren't allowed to travel, including folks who work for some of the NASA labs and some of the other government labs. People have lost a lot of funding. I imagine, though I don't know for sure what the numbers are like, that a lot of international people just didn't want to come because they're, worried about getting stopped. So it was a significantly smaller conference. It was still pretty big, but it was significantly smaller than it was the previous year because science is really hurting right now with the budget cuts, the loss of grant money, the shutdown, a lot of government employees being told they couldn't travel. A lot of government employees have either lost their jobs or left their jobs. I got word while I was at the conference that the biology division of the National Science Foundation has lost a significant number of employees, and now they have to completely restructure everything. So they're going to be able to review fewer proposals for money, basically, because this is how science is conducted. In the United States, most of the money that pays for science is government money. It comes from government agencies, and we have to apply for that money, and it usually takes several rounds of submitting a proposal and getting rejected and submitting it again and getting it rejected until we can get that money, if we get it at all. And that money pays people's salaries, and it pays for equipment, and it pays for supplies. It's very, very expensive to run a lab. And a lot of folks are losing that money. And so they can't travel to conferences. They can't do the science that they had originally planned to do. So I mean, a lot of that was, Doge, which seems to be kind of winding down now, but um, the guy Russell Vought, the budget guy, is just like basically trying to privatize everything.
Yeah.
Um, and it's pretty bad out there. So it was kind of like not really talked about directly in a lot of the sessions, but when we all got together for drinks or dinner afterwards, we were all kind of speaking in hushed tones about how worried we all are about science and the damage that is being done and how long it's going to take to recover from the damage that's being done right now.
Yeah,
Um, like,
science is hurting, man.
yeah,
Of all the things to take away,
laboratories are
science, like,
literally being bulldozed. Government laboratories are being bulldozed. The NSF building got cleared out so that the HUD secretary could move in. I mean, it's bad. It's really
yeah,
bad.
it's getting ridiculous out there. But
Yeah.
one
So,
day,
uh, if you're a politically minded person, or even if you're not, if you love science as much as we love science, and we assume that you do, because that's why you're listening to this podcast, you call your representatives and make a big stink about it.
for real.
Because they work for you. That's their whole job is to represent you in government. Tell them that you're concerned about science funding in this country because you should be. We all should be. It's pretty bad out there. You can take it from me, someone who is a scientist and who works with scientists. We're all very, very worried about our
Yeah,
jobs, about the future of science in the U.S. It's not a good scene.
and I was gonna say, like, I think you guys will come to learn too that without science, everything sort of falls apart because it all goes back to science. The computer games you're playing, like the computers you're getting, the chips that are
Hmm.
made for computers, the chips that are made for the TVs you watch, like all that stuff doesn't exist without science. So it's
Not to
kind of
mention the
necessary.
effect on public health,
Mm-hmm.
all of the research on public health that is being taken away because we have a health secretary that doesn't believe in vaccines. Um,
Yeah,
so
we need
like
science.
we need science, you guys. There's that whole speech that Robin Williams gives in that movie. The one where he's the teacher.
Oh my
Uh,
gosh. Oh, Captain, my Captain. Dead Poet Society.
yes, Dead Poet Society. He gives that whole speech about how, medicine and technology and engineering make our lives better, but poetry gives us a reason to live. And like, yeah, I believe that poetry gives us a reason to live, but science gives people a reason to live too. It doesn't just make your life better. It is a noble pursuit in and of itself. It doesn't have to be about, how is this going to benefit humanity? How is this going to invent the next big tech thing that we can invest in? It can just be, isn't it cool that we understand the world around us a little bit better now than we did before? That is a reason to live. It's a reason to get out of bed in the morning. It's the reason I get out of bed in the morning. So, like, we need science because it makes our lives better in material ways, but also in all of these emotional and philosophical ways too. It's cool that we understand all of this stuff about the world that we didn't understand before. I think that isn't emphasized enough when we talk about science. We talk about all of like the material benefits, like here's how science makes your life better, and here's why we need to invest in it because it's going to make people money, it's going to make people live longer, it's going to make your phone work faster, whatever. That's great. It's all true, but also it's just really good for us as a species to know more about the world. We are an inquisitive species. Our whole thing is learning about the world around us and naming things and dissecting them and taking them apart and figuring out how things work because we're curiosity driven. It's what makes human beings so cool. So like let's continue to do that. We
Mm-hmm.
don't have to put this practical spin on every single thing. It can just be we're learning about the universe and we're learning about the world because that's important. It's important to invest in as emotionally invest in, not just monetarily, but put yourself into it because that's what makes being a human being so interesting is our curiosity, our inquisitiveness, our exploratory nature. Uh, I'm tired of everything having to be like, well, what's the practical application? How does this benefit people, from a financial standpoint or whatever? I don't, eh, that's great and all.
And if you pledge
But
$200 to science, you'll get this nifty tote bag. $300 gets you the mug, and $400 gets the Andrea Bocelli CD.
Right, exactly. It's like I just don't need there to be like an obvious instant gain from the things that I study. I study them because I think they're fascinating.
Well, it's the
And
instant results. Like, that's the problem. People don't see the instant results with it because it takes years and years. That's another episode later on down the line because we could go on for hours. But I think it's time to
absolutely.
keep this one moving and wrap it up. So
Yeah, I guess we'll have to wrap this one.
I didn't write a song for the conference because we just got the idea to do this one the other day. But next week next episode we're going to talk about bioluminescence. So that's going to
Oh,
be cool.
yes. Yeah.
I've started
How do
kicking
things
around.
grow?
Yes, I started kicking around a couple ideas with my knowledge on it. So, Lauren, I'll be looking to you to help me fill in the blanks on those lyrics. But yeah, it'll be really cool.
Oh, I'm there. I'm so ready.
Yeah, I'm excited. If I can pull this one off, it'll be impressive because it's a lot of words, but I think you'll like what I have in mind for it. But yeah, that's gonna do it for us. So, Lauren, your homework is to get us into Glasgow 2026. Preferably
Yes,
for
sir.
free, but if we need to figure it out, we need to figure it out. Uh, and you know what? They don't even have to pay me. They can just pay for my greens fees. It's fine. I don't care. And don't forget to like and comment and subscribe to our podcast, which is everywhere. It's on iTunes, it's on iHeartRadio, it's on YouTube, it's on Amazon Music, it's everywhere pretty much that you get
Woo, look
podcasts.
at
So
that.
we're like Pitbull, we're Mr. International, Mr. Worldwide. We're like, yeah, Mr. Worldwide, not Mr.
Wow.
International. Austin Powers, International Man of Mystery. That's us. So yeah,
Exactly.
we are internet
Yeah,
wide, people.
baby.
Which kind of sucks because it's a lot harder for me to keep track of our listenership, but that's okay. We have 9 Spotify subscribers, so we're ahead of the curve of where I thought we would be by now. So that's pretty rad.
Wow.
Yeah,
Thanks, guys. We love you.
Yeah, let's get more out there because 9's cool. Like 9's way ahead of most podcasts after 3 episodes. So 9's really rad, but we need that multiplied by 100 to be super rad. Get it?
Yeah, let's
Aquabats.
keep
Yeah.
spreading the good word of science.
Yes, spread the word, like, comment, and subscribe, and tune in for our next episode of Bioluminescence. But that is all. So I will wish you guys all, well, I guess it's post-Christmas, but I hope you guys all had a good Christmas and a happy New Year and good holidays and all that stuff. Yeah, that's it. So take it easy, guys, and say goodnight, Lauren.
Good night, Lauren.